On June 28, 2009, Stephen Hawking threw a party. Champagne on ice, balloons, a banner reading "Welcome Time Travelers." Then he mailed the invitations, the day after it ended. The only way to attend was to come back through time. He sat in that room. He waited. Nobody came. If time travel is possible even once in the entire future of humanity, our present should be crawling with visitors. It is not. And the reasons physicists give for that empty room are stranger than science fiction. Subscribe, and let's open every door in that silent room. The party was real. Cambridge University, June 28, 2009. Hawking called it an experiment. He set out champagne, hors d'oeuvres, and a hand-lettered sign giving the exact GPS coordinates and time. Then he waited until the event was over before publishing the invitation in a Discovery Channel special. Any traveler from the future, no matter how far ahead, could have read those coordinates and simply appeared. His logic was brutal in its simplicity. If time travel is ever invented, at any point in the next million years, someone should have shown up. The chair stayed empty. Hawking called the result experimental evidence that time travel to the past is impossible. But impossible is a big word in physics, because every reason it might be impossible opens a door onto something worse. And the first door is a wall built into the machine itself. Here's the first strange rule. The physics of a real-time machine, a traversable wormhole, a rotating Tipler cylinder, a Kerr black hole ring, has a hidden clause almost no science fiction obeys. You cannot travel back further than the moment the machine is switched on. Kip Thorne worked it out at Caltech in the late 1980s. A wormhole is a shortcut between two mouths in space-time. To make it a time machine, you drag one mouth at near light speed and bring it back. That process creates a closed time-like curve, but only stretching back to the second the loop was first closed. So even if humanity builds the first time machine in the year 3000, no traveler from 3001 can visit the Roman Empire. Or Cambridge in 2009. They can only reach the year the door was first opened, which means Hawking's empty room might not be evidence of impossibility, but that the machine has not been built yet. And that is only comfort until you ask what stops us building it. In 1992, Stephen Hawking published a paper with a chilling title, The Chronology Protection Conjecture. His idea was that the laws of physics themselves conspire to forbid travel to the past, not by locking a door, by destroying anyone who reaches for it. Every time the universe seems on the verge of forming a closed time-like curve, some effect appears at exactly the right scale to prevent it. Quantum fluctuations pile up, virtual particles cascade. The would-be time machine tears itself apart before the loop can close. Hawking wrote that this conjecture makes the universe safe for historians. It is a beautiful line, but read it again. It means the universe has a defense mechanism. Something at the level of physical law is watching for causal loops and killing them. We do not know why, we only know the math keeps producing this same guardian. And the next door explains what that guardian might be made of. The guardian may simply be energy. Every serious blueprint for a time machine needs something we have never held in our hands, negative energy or exotic matter. To keep a wormhole's throat open long enough to walk through, you need a substance that gravitates outward instead of inward, a stuff with negative mass. Kip Thorne and Michael Morris calculated in 1988 that the amount required for even a small human-scale wormhole would be roughly the mass energy of Jupiter, converted into this exotic form. For a larger, safer passage, you might need the negative energy equivalent of an entire star. In laboratory experiments, the Casimir effect between two plates, we have detected tiny hints of negative energy density measured in fractions of a joule. Building a time machine from that is like trying to boil the ocean with a matchstick. It may not be forbidden. It may just be forever out of reach. But if you did find enough, the machine might still tear itself apart before you step through. This is the moment most wormhole time machines die. The instant a closed time-like curve forms, light and quantum vacuum fluctuations can enter the loop, and travel around it again and again and again. Each pass adds energy. Each pass amplifies. In a fraction of a second, the pileup reaches infinity and the wormhole detonates from the inside. Physicists call it the blue shift catastrophe. Hawking himself pointed to this as the mechanism behind chronology protection. Imagine whispering into a microphone connected to its own speaker. The tiny feedback becomes a shriek, becomes a scream, becomes a blast that shatters the equipment. The universe, it seems, does the same thing to any door opened onto its own past. The traveler never even makes it through. They are erased with the machine. And yet, even if a loop survived, the traveler inside would face a rule stranger than the explosion. In 1989, Russian physicist Igor Novikov proposed a rule so elegant it made the grandfather paradox vanish. His self-consistency principle states the only journeys through time that can happen are the ones that do not change anything. The universe is a single self-consistent story. If you go back to shoot your grandfather, your gun jams, your aim wavers, you slip on ice. Whatever it takes, the timeline stays whole. Not by magic, but because inconsistent histories have zero probability. They simply do not occur. Novikov and Thorne tested it with mathematical models of billiard balls going back in time through wormholes to knock their earlier selves off course. Every solution the equations produced was self-consistent. Every paradox smoothed itself out, which means a traveler could visit our present, but could never do anything to prove it. No selfies, no warnings, no revealed name. If they came, we would never know. Unless they came from a place where our rules do not apply. Hugh Everett proposed something in 1957 that quietly rewrote reality. Every quantum event splits the universe into every possible outcome. Every choice, every collision, every photon that could have gone left or right, all of it happens in branching parallel worlds. Apply this to time travel and the paradox dissolves in a colder way. A traveler going back does not enter our past. They enter a new branch, a fresh timeline that separates the instant they arrive. They can shoot their grandfather freely because that grandfather is not theirs. He belongs to a copy of history, which means our timeline may have hosted no visitors, not because travel is impossible, but because every traveler who ever came went somewhere else. A near-identical Earth, one branch over, where a stranger arrived in 2009 and drank Hawking's champagne. We just are not in that branch. And that thought leads to a darker question. What if the ones who could reach us are hiding on purpose? Chinese author Liu Cixin gave us the dark forest solution to the Fermi paradox. Aliens stay silent because announcing yourself in a universe of unknown predators is suicide. Apply the same logic to time. If the past can be edited, even slightly, even by accident, then any traveler broadcasting their presence hands enemies, rivals, and paradox hunters a target that reaches backward. A rival civilization in the future could send an assassin to the moment a traveler was born. A political faction could rewrite the past to erase them. Even their own descendants could stop them from ever leaving. Under those rules, the only rational strategy for a time traveler is total, permanent invisibility. No records, no relics, no revealed identity. Ever. The empty room at Cambridge is not evidence of absence. It may be evidence of discipline, of a rule so absolute that even Stephen Hawking, waving a banner in champagne, could not tempt a single visitor to break it. And yet, a darker possibility whispers underneath. Economist Robin Hanson coined the phrase "great filter" in 1996 to explain the Fermi paradox. Somewhere in the long chain from lifeless chemistry to interstellar civilization, there is a barrier almost nothing gets past. It could be behind us in the leap to complex cells, or it could be ahead, a wall no species has ever crossed. Now apply it to time travel. Building a functional time machine requires energies and technologies far beyond anything we possess. If civilizations reliably destroy themselves through nuclear war, climate collapse, engineered pandemics, artificial intelligence gone wrong, long before reaching that level, then the future capable of visiting us never exists. Not in our timeline, not in any timeline like ours. The reason no traveler comes to 2009 is not that they refuse. It is that they never got the chance. The species that would have built the machine died before finishing the blueprint. And if some did survive, they may already be here, watching. There is a gentler possibility, and it is almost worse. What if they do come, and they simply do not touch anything? We study wild animals with hidden cameras, camouflage blinds, drones that never land. We do not shake hands with the deer. We do not warn the ants about the flood. A civilization capable of engineering closed time-like curves may treat our era exactly the same way. Careful, silent, non-interfering. There would be no wave in the crowd. No stranger at Hawking's party. Only observers in the folds of history, taking notes on our wars, our art, our first stumbling steps toward AI, and leaving without a footprint. Some physicists half-jokingly call this the zoo hypothesis of time travel. And if it is true, then the eerie feeling you get sometimes, that unblinking sense of being watched by something you cannot name, may not be paranoia. It may be the closest we ever come to meeting them. Here is a possibility that hurts a little. Out of the entire span of human history, past, present, and future, what makes 2009 special? Or 2024? Or now? If you had a time machine and unlimited fuel, would you spend it visiting a random Tuesday in a random suburb? Historians dream of ancient Egypt, the burning of the Library of Alexandria, the first landing on the moon, the moments a war began or ended. Our current sliver of history may simply not rank, no pyramids being raised, no world-ending war on our doorstep, no first contact yet. To a traveler with access to every year in the human story, our present may be the equivalent of channel surfing past a rerun. Hawking's party was not skipped because it was dangerous. It was skipped because it was ordinary. And if that is true, it means our era is quiet, uneventful, and blessedly unremarkable. Or it means something worse, that there is no one left to look back. This is the answer that keeps physicists quiet in interviews. Every previous reason assumed a future exists, a future with rules or machines or observers or descendants smart enough to hide. But what if the silence is simpler than that? What if no one came back? Because there is no one left to come back. A great filter ahead, a collapse we cannot yet see. Somewhere in the coming centuries or millennia, the human story quietly ends, and the machine that would have carried a traveler home to Cambridge in June 2009 is never built, because the hands that would have built it are gone. Under this reading, Hawking's empty room is not a paradox, it is an obituary mailed early. The banner still says welcome. The champagne still waits, and the future stares back through the doorway with nothing in its eyes. No visitors, no enemies, no observers, just the quiet that follows a story that ended before it learned how to loop back on itself. This is the answer no equation can rule out, and it is why some scientists refuse to sit in that chair for very long. 12 doors. 12 reasons the chair at Hawking's party stayed empty. A locked machine, a guardian in the laws, a tearing loop, a universe that smooths every paradox, a branching tree that hides every visitor, a dark forest of time, a filter no one crosses, observers who never wave, or the quietest answer of all, that the future is not hiding. It is simply not there. Which of these 12 chills you the most? Which one do you almost hope is true? Tell us in the comments. The banner still hangs, the champagne is still cold, and somewhere ahead, someone or no one is deciding whether to come.